What's up, people? I'm back. Are you ready? I know you are. Okay, so today we're going to take on proportional graphs part 2, and we're going to start out by talking about a little review action here. We're going to do a little unit rate problem with some fractions. So, if you remember, when you do unit rate, that means you're going to do a specific operation. So, when you do unit rate, that means you're going to do what? Alright. That means you're going to do some dividing. Alright, unit rate means you're going to divide. So make sure you got your notebook out. Make sure you're taking good notes. And here we go. So let's say you know this. Let's say Tommy, who used to work on the docks, okay, worked $3 hours for every 3/5 dock. Alright. So, how will we do that kind of problem? So, that's hours per dock, okay? Hours per dock. So that would be 3 divided by 3/5. So remember that that's a whole number, that's going to be over 1, right? Then you're going to multiply by the reciprocal. So of course that would be 3 over 1
times 5 over 3. You could then cross reduce those little suckers. 1 goes into 3 goes into 3 one time. 3 goes into 3 another one. And that means 5 hours per dock. So while Tommy was working, he'd be on the dock 5 hours per dock. Okay? We'll get back to Tommy later. Okay. So there's your review. Alright, let's talk about a couple other things we've got here. Okay, so when you've got a set of these points, let's just say we've got some of these. Let's say you know that you've got a point. Of course, you got to have a point at 0, 0. Of course, that's the origin. You know it's got to start there. Otherwise, it wouldn't be proportional. Let's say your next one is at 1, 7, and your next one's at 2, 14, and your next one's at 3, 21. Okay, so let's say you graph all those. Okay, and of course, remember it's got to be linear. And it's got to go. You can go through the origin, so we already know it's going to go to the origin because we got 0, 0. Then, of course, if you graph it, it'd be linear. So my question would be, all right, if you kept that going, where would 4 something be graphed? Okay. Well, you look right here. Okay. If you look at this one that's got the 1 in the X spot. Okay. That tells you right there what your unit rate is. Your unit rate or your COP is 7 because 2 times 7 is 14. And 3 times 7 is 21. So 4 times 7 would be what? 28. So the next one you would graph would be 428. Okay? So my question to you would be, alright, let's say we take it on up to 9. What would you graph at 9? You'd go 9 what? Okay, so we come over 1, 2, 3, 4, 5, 7, 8, 9. Then what would we have to go up to on the y-axis? It would be 9 what? Well, again, of course, you'd do 9 times 7. Do you know what 9 times 7 is? 9 times 7 is 63. Alright, hopefully you got that right. Okay, so you may have some of these problems where it's asking you to figure out, hey, we've given you these, what's the next one going to be, or where is this next one going to be? Always look, okay, at this one right here. This one is the key to the whole shooting match, the one that's 1 whatever. 1.5, 1, 2.5, 1, 8, whatever. That's telling you at 1 your unit rate's going to be 7, okay, or your COP is going to be 7. So that's the one you always want to look for. Okay, so now if you'll take out your book, people, if you've got a book, of course, some of you don't have a book, but if you do have a book, of course, that's the one with the marlin on it. Hey, the marlin. Hello, Mr. Marlin. And we're going to do a couple of these together. So I've got some pages here I'm going to pull out of your book. And we're just going to talk about a couple of these tables just to review a couple more things. All right, going to try to do these quickly. And if you got questions, y'all just email me or let me know. I'm pretty sure at this point you're probably doing pretty good with it. So I've got these tables here. Of course, there's 0, 0, so of course you'd have it there. 140, that would be 280, 3, 120, 4, 160, so we're just graphing these, 5, 200. Alright, so again, these are your X numbers, which of course are running down here, the pairs of sneakers, and then these of course are your Y numbers, how much revenue you're getting when you sell them. So when you hook all those together, okay, it's going to look something like that, and it'll keep going. So is that showing you a proportional relationship in that table? Is it showing you a proportional relationship? What would you say? Would you say yes or no? I'm hoping you'd say yes. Okay, and how do you know it's showing you a proportional relationship? What would you say for that? Okay, well, you know, because the unit rate, or COP, whichever way you want to say it, equals 40 in all those, right? 40 divided by 1 is 40, 80 divided by 2 is 40, 120 divided by 3 is 40, 160 divided by 4 is 40, 200 divided by 5 is 40. So for all these you get 40, 40, 40, 40. Okay, that's one way you check it, right? You do the Y divided by the X, okay? Y divided by X, and in all those situations right up there you get 40. So that's how you check it in the table, right? So we got those in the table, we graphed them over here, so we got them. So of course that would be zero. I mean, if you're going to write them as ordered pairs, that'd be 0, 0, 140, 280, 3, 1. Make sure you're putting them in parentheses like I'm doing, right? Put them in parentheses. 3, 120, 4, 160. Not a very good 4, is it? And 5, 200. So that's how you'd write them all in ordered pairs. Again, make sure you put them in parentheses. Do they make a straight line? So are they linear? And what would your answer be for that? Yes. Does it go through the origin? And that would also be a yes. Okay, so you can see that that all is going to work there. Okay, it's a proportional relationship. Check the table by finding your unit rates. Check the graph by seeing if it's linear and does it touch the origin. So there's that one. Okay, let's go down here to number 2 then. Scoop this down a little. Scoop that back. Get a little more room here. All right, Maya is selling some spices at the craft fair. So down here we've got cumin, and you've got your tablespoons of cumin as your X value, and you got your chili powder up here. I guess it's teaspoons, not tablespoons. Teaspoons of chili powder here. All right, so you got 1, 4, 2.510, 416, 520, 4.518. So you got some different ones on here. Okay, so what does the origin represent in this particular problem? We know what that means. Maya hadn't sold anything yet. Okay, so down here she hadn't sold anything because there's no cumin and there's no chili powder. So what does that origin represent? She has not sold anything yet at the craft fair. Okay, maybe she's still setting up the table. You know, maybe she hadn't even got the stuff out of the car yet. Okay, so that means, of course, she hadn't sold any cumin. That's a 0, and she hadn't sold any chili powder. So that's also a 0. So they're both 0. All right. What are the coordinates at point x equals 1? All right. So again, the x-axis is this one. So if you come to x equals 1 right here, of course you can see that the y value is 4. Okay. So when the x is 1, the y is 4. All right, and that represents, okay, for every 4 teaspoons of chili powder, you're going to get 1 teaspoon of cumin. Okay, every 4 teaspoons of chili powder. She sells 1 teaspoon of cumin. Alright, and of course if you put that in an ordered pair, the X will come before the Y, so that would be 1, 4. And like we were talking about over here on this other page, okay, remember, when you have the one that's got the one whatever, that's the key to the whole thing. So what is the unit rate for this, or the COP? 4, okay? The unit rate here is 4. So you can put COP equals 4. Alright, that's just a little bonus I'm throwing in there. Alright. Why the graph shows a proportional relationship. Alright, so why is this proportional? Well, at this point we should know the two things, right? It is linear. That's number 1. And number 2, what else is it besides linear? Linear, sorry. It touches the origin. Which of course is 0, 0, which of course is right there. Now, I'm going to just talk just a second about these questions about solid lines and dotted lines. All right, I'm not totally really worried about this, but I'm just going to throw it in there, okay? So it says, okay, in your text and stuff, the reason that it's, this one's got a 2.5.
Right, there's it's 2.510, and that one's 4.518, so that means it can have decimals. So, you know, I don't really care if you know about the solid line, dotted line thing, but if you want to know the reason it's a solid line, because these can be any non-negative number, including decimals and fractions. And I'm just going to throw that in there. I don't think that's anything I'm going to be giving you any quiz questions on or anything, but since it's in here, we might, you know, I figured I'd talk about it. So since this can have decimals in it, okay, you could have 1.5 teaspoons of cumin, or you could have 1.5 teaspoons of chili powder, or you could have 4.5 teaspoons of cumin, or whatever. So you could have half teaspoons. So just want to let you know the difference between the dotted line and the solid line. All right, let's go to the next page. All right, so we're over here about the lemonade and the graphic t-shirts. Okay, so now we're on page 29. This is in your book, page 29, or you can look at the PDFs. Just a couple more minutes and that'll be all that we need. I'm pretty sure y'all probably got most of this figured out. Okay, so here of course we've got our servings. Here we've got our water. We're making lemonade, so the servings are the X, the water is the Y. So at 1 cup of water you have 2 servings. At 1.5 cups of water you got 3 servings. At 3 cups of water, oh, I think I might be doing that wrong. Sorry. Let's go back. So at 2 servings, you got 1 cup of water. At 3 servings, you got 1.5 cups of water. At 6 servings, you got 3 cups of water. At 8 servings, you got 4 cups of water. Alright, those over there, they're wrong. If you got a pencil, I hope you're doing it pencil, not pen. Alright, so when you put all those together, okay, it's going to look a little something like this. Okay, now, is it a proportional relationship? And you would say what? Well, is it a straight line? Yes. Does it touch the origin? Yes. So those are your two things we just talked about on the other one. Yes, it's linear, and yes, touches the origin. So if it does both of those things, you know it's a yes. Now, I put it down here as a solid line. Okay, again, it's a solid line because why? Well, it's got that little fraction part in there right there. You see that where it's got the 1.5. Okay, that is, you know, that's meaning it could be any non-negative number. So this should be a solid line, not a dashed line. Most of them we're going to do are going to be solid lines. Okay, most of them are going to be doing that. All right, and then C says what's the constant of proportionality, and write an equation. So right here we can go to 1. Okay, so on the X you go to 1. And then you go up to where it crosses here, and that would be a half. So So the x is 1 and the y is a half. So that means for one serving, it would be half cup of water. One serving would be half cup of water. So y equals 1/2 x. Y equals 1/2 x. So like if you go here, you can see that 6 servings would be 3 cups of water. So of course 3 divided by 6 would be a half, or 4 divided by 8 would be a half, or you could go back to the first one right there, and of course that would be 1/2. So just remember, it's always y divided by x. The COP for this, of course,
would just be a half. Because that's a half, and that's a half, and that's a half, and that's a half. And your equation will be y equals 1/2 x. Alright, coming on to the home stretch here. Alright, down this one, the reason it's dotted is because it's talking about the number of boxes that you would order for some t-shirts here. So you got number of boxes and then total number of t-shirts. So you couldn't order half a box of t-shirts. You couldn't say, oh, I want to get 1.5 boxes of t-shirts or 3.5 boxes of t-shirts. You're going to order a box, 2 boxes, 3 boxes, 4 boxes, whatever it might be, okay? So you can see how here they've got it dashed. If you draw it solid, I'm not going to get excited about it. That's all right. So is this a proportional relationship in this graph? And you would say what? Yes, because it's making a straight line. You know, it's linear. It's touching the origin. All right, what's the constant of proportionality? So we go right here where it's 1 and 50. Right here, this is the one you want to look at, 1 and 50. So what's the COP? So the COP, of course, is 50. If you had to write a graph or an equation for that, okay, that would be y equals 50x. Again, remember to write it all lowercase and don't put any spaces in there. And again, the reason this is dashed, because instead of it being solid, is because you cannot order half a box of shirts or, you know, a quarter box of shirts or whatever. You're going to order Tommy a whole box. If he's going to be down there working on the dock, and order the whole box and get the whole box off the ship or whatever before he puts it on the Amazon truck to bring it to your house. Alright, so there you go. Here's your riddle of the day. Let's say Tommy goes on vacation and he wants to know, when he looks up stuff on TripAdvisor, why does a vacation in the mountains cost more than a vacation at the beach? He's wondering about that. Why does a vacation in the mountains cost more than a vacation at the beach? So figure that out. Also, you can email me the name of this here song about Tommy and the docks, and make sure you email me the name of the band. Of course, if you want real extra credit, you can email me all the names of the band members. One of my all-time favorites. I went to see them a lot in concert when I was growing up. So just let me know. And next time, we'll be talking a little bit about something else. But today, that's all I got for you. So sayonara, peace out, hasta la vista, baby. And we'll talk to you soon. Stay healthy, stay safe. Bye.